Hello, my name is Bora Yavuz, and this is my Physics 101 project on projectile motion using a tilted air table. The aim of my experiment is to verify two theoretical results, that the horizontal range is maximum at a launch angle of 45 degrees, and the maximum height is reached at 90 degrees. I used a spring launcher and pulled it back to the same mark each time to keep initial speed roughly constant. The air table was tilted with a wooden block so that sin theta is equal to 0.60. Here you can see the pilot 1, which shows the horizontal range x maximum as a function of the launch angle theta. The overall shape is consistent with the theory. The range is largest near 45 degrees and smaller for both lower and higher angles. However, the experimental curve is not perfectly smooth and some angles do not follow the ideal symmetric theoretical graph. But most of the deviations are caused by spring launcher. Because I could not compress the spring in exactly the same way for every shot, so the initial speed was slightly different from trial to trial. Here you can see pilot 2, which shows the maximum height as a function of launch angle. As expected, the height increases with angle and is largest at 90 degrees, and the small irregularities in the curve mostly come from small changes in launch speed and the angle between shots. Here you can see pilot 3, which shows the sample trajectories in the XY plane for different launch angles. Each curve is parabolic paths reconstructed from the measured range and maximum height, and the small distortions from the ideal shape are mainly due to slight variations in the spring compression and alignment. Ultimately, this project showed that the range is maximum around 45 degrees. The maximum height is reached at 90 degrees, and the vertical acceleration of the tilted air table is close to theoretical value. The small differences between theory and experiment can be explained mainly by variations in spring compression, limited angle control, and residual friction. Overall, the results are consistent with the standard projectile motion model from Physics 101. Thank you for watching my presentation.